Welcome to this episode of GenAI Live. My name is Brian Terry, and I'm a Senior Partner Solution Architect here at AWS, focusing primarily on GenAI migrations to AWS Bedrock. And I'm here with my co-host, Wayne. Wayne, how are you doing today?
I'm doing well, Brian. Thanks for kicking us off. Hi, my name is Wayne Sachs. I'm a partner solutions architecture leader here at AWS, where I work with partners, all day long, every day, helping plot the course of their development on and around the AWS platform. And obviously, in many ways, Gen AI is a big part of what we talk about constantly because, it's the future. And
It
that's
is.
why we're here.
Yeah. And this is your first time joining us. We're super happy that you're here, and we hope that you join us every Wednesday at 8 a.m. to 9 a.m. Pacific Standard Time for the latest and greatest in what AWS is doing with our partners in the Gen AI space. So today, Wayne, we have an awesome show. We have a couple awesome partners that are going to talk about some great innovation in the Gen AI space.
Yeah, I'm excited. I think, as always, every week we get to meet with new partners and talk about the ways that they're sort of approaching this new technical revolution, what their customers are asking for, and ultimately, like what they've built to go, meet their customers' needs. And it's always inspiring because, like, the variety of things that we get to hear about on a weekly basis is um, astounding, right? Like, we see
Yeah.
everything.
Absolutely. I mean, this space is just going, just innovating. Like everyone's innovating from week to week, and I love to see what partners are creating, what AWS is building, and it's super excited to see the trajectory of where this is going. And I'm sure in the next year or so, we'll have some some crazy inventions in the
Yeah,
GenAI space.
there's no question about it. I don't own a crystal ball. Definitely can't. I definitely cannot see the future. But I would be, willing to bet any amount of money, mostly small, that we couldn't even imagine what our conversation will be like in a year's time. Like I have a feeling that whatever that conversation is going to be about is about a bunch of stuff that has not yet been invented. Um,
Yes. Yeah. So let's talk about a little bit of news. What's going on in Gen AI? So I know it's summit season right now. So
yep.
AWS is putting on a lot of summits. For you who have never been to a summit is like a mini reInvent that's actually free. You can actually go and see what's going on with the AWS ecosystem and its partners, and seeing what's going on in Gen AI, and just experience the latest and greatest in technology. And in this week, if you happen to be in Japan, it actually kicks off today and tomorrow. But we
Yep.
will have some other ones in America coming up soon. I think New York, I think is the next one.
Yeah, we got New York coming up. I think we just did Reinforce, and that was not technically a summit, but also
Yeah.
very cool. And I think there was a lot of discussion there about generative AI inside of some of these other, like the traditional security services, guard duty, inspector. The ways that we're approaching making some of these security services enhanced with the capacities that we all kind of can imagine Gen AI brings. New York is coming up. That's going to be a big one, undoubtedly, inside the Javits Center in New York in the middle of July.
Yes, yes. I know I'll be there. So, like, if
Yep.
anyone from the audience is going to be there, please come by the Gen AI booth. I'll be there. And yeah, I'll be happy to speak with you.
Yeah. No, and that's I always love the New York Summit. First of all, because I just enjoy going to New York, but also because there's like the crowd is just like vibrant. There's so much energy in the room. There's usually some pretty cool announcements. There's always tons of partners. Um, and just like the opportunity to learn a whole bunch of stuff. And like you said, it's almost like a mini reinvent, especially the New York Summit. Like it's big. There's a lot of stuff that happens.
Absolutely. I'm excited to go. I mean, I'm excited, super excited. I mean, I think it's what, three weeks away or so.
That's right.
Yeah, yeah. So, what
All
about
right.
you? What have you noticed in Gen AI this week?
Well, what have I noticed? We've been talking. I've been working with partners, really thinking through the the partner's approach to constructing agentic platforms, and really like What I really appreciate is my partners who are really focused on customer outcomes and kind of working backwards to what does the platform need to look like.
Mm.
And there's different ways to think about it, different approaches that people are taking. The technology is obviously really critical, but one of the things that I think my partners are really focused on, and I think our customers are really appreciating, is that we're really centering on, in particular, like complex business processes that were not really tackleable
Mm.
even months ago. Um, Things that
Wow.
are complicated, things that are expensive to operate, things that may be brittle or prone to failure or prone to failure modes that were unpredictable that can now be addressed in using the tools that that AWS is providing, models and agents
Wow.
rock.
Super
Um,
exciting. I mean,
it-
yeah, that's awesome.
there's like nothing better than sitting there with a partner and a customer and you sort of like having that moment where everybody's vision is just like, holy moly, we can now do this. Like we've had this big rock and we've constantly tripped over it, and now we can solve it. It's just really cool.
That is super
Uh,
awesome. Well,
We've also been
well,
spending a lot of time on Transform because I think Transform generally,
uh,
like, it is awesome, does really incredible things. We're seeing huge improvements in our ability to do a couple like complex code refactoring, documentation. It's really like there's some really cool stuff that's happening in that space too. So anybody who hasn't spent some time there, like, definitely worth your while.
absolutely. I've seen a lot of partners and customers use it into my migrations.
Yeah.
It's a great tool. I'd highly recommend it also.
Yeah. All right. Let's. I bet we're not that interesting, but I bet our first guests are. Shall we bring them on?
Absolutely. Hello. Welcome to GenAI Live. So, how about you introduce yourself?
Yeah, of course. Thanks first of all for having us. I know we've watched this segment in the past, so we're really excited to be here. To quickly introduce myself, my name is Katya, and I lead the AWS pre-sales team here at Adastra. I've been with the company for a little over 6 years now. I've been in this role for about 3 years, and prior to that, I was actually leading our AI practice. So I've had a lot of exposure to the cloud and kind of AI world. But in my role today, I work closely with organizations of kind of all shapes and sizes to understand their pain points, business objectives, and then help shape the right kind of analytic solutions or data strategies to solve those pain points. Of course, aligned to AWS technology. And lately, as you can imagine, a lot of those conversations are very much centered around Gen AI. And it's been really exciting to see kind of all the different creative use cases that are kind of emerging across all these different industries. And we've obviously seen how quickly this space is evolving. I feel like every week there's something new. So that's been really exciting to see. And yeah, definitely excited to share some of what we've been doing today. And I'll hand it over to Moj to introduce yourself.
Yeah, hi, I'm Maj, and with that scientist with primary focus on generative AI. We work closely with customers to design, build, and scale GenAI solutions on AWS, and we help clients turn innovative ideas into practical and production ready systems. And we spend a lot of time exploring the cutting edge of technology and collaborate with cross-functional teams to solve real world challenges using AWS's powerful AI services. Excited to be here.
Well, thank you for being here.
Yeah, no, love it.
Thanks for
Thank you
having
for
us.
joining us. We
Yeah.
love talking to partners like yourself. So let's just get to let's get to the heart of it. So what are you like? What are you seeing from your customers? What are your customers asking for you and for you to do for them?
Mm.
Yeah, I mean, great question. And I mean, I feel like my answer to this changes probably on a weekly basis with all the advancements that we're seeing, especially in the last couple of years. If we're talking about, I guess, like latest trends that we've seen, I think one of the biggest shifts that we're seeing in the Gen AI space right now is the move beyond kind of simple retrieval agents and chatbot style applications to more of agentic type architectures. Obviously, there's a growing interest in agentic AI where kind of multiple agents start coming together to reason over complex workflows and interact with different systems and data sources to actually get things done and take action rather than only providing information or summarizing text. So definitely seeing a shift towards these more intelligent autonomous systems. And we've been investing in a lot of solutions internally to help our customers build these agentic architectures. I think what else we're seeing is momentum around kind of multimodal capabilities. So not just dealing with text, but also images, audio, even videos being brought into these GenAI workflows. So that, of course, kind of opens an entirely new category of use cases, especially in industries like manufacturing, retail, media. And I can kind of share an example here. So we recently worked with a leading media company in Europe. So they own and operate a bunch of different TV channels, radio stations across regions. And as part of their radio business, they were actually producing a number of nighttime broadcasts and content that was pre-recorded. It was like a mix of music, different spoken segments, intros, outros between songs. And every day they were spending a lot of manual effort kind of curating, pre-recording those nighttime broadcasts so they could distribute them to different radio channels. And they had this vision of leveraging large language models to dynamically curate those nighttime broadcasts and localize them to the different regions. So Dastra came in and kind of designed and implemented an agentic solution to automate that entire process, essentially handling music curation, scheduling, speech generation on a daily basis, and then distributing the final products to their radio partners. So it's a pretty neat, I guess, multi-agent solution. The final product was one like a scheduling agent that curated all the playlists and timings, decided what song to play. It created like gaps for the different like breaks or announcements. And then this like script writing agent that essentially drafted all of the spoken segments, like the voice intros and promos, and tailored them to each region. So those agents combined were able to like dynamically create nighttime broadcasts and also personalize them to the different segments. So quite powerful. I think it resulted in about a 60% reduction in operational costs without the need to do them manually. I guess another trend that we're seeing is the move beyond just kind of static, unstructured knowledge bases and LLM solutions. We're seeing customers wanting to integrate their LLMs with operational systems and databases, so allowing kind of real-time integration with structured enterprise data stores instead of just unstructured data. Which has involved a lot of text to SQL translation modules that allows kind of their users to query operational databases and reduce kind of that burden on IT teams to constantly produce KPIs and reports and really democratize data and analytics to their business users to get those insights. So those are some of the interesting trends we've seen in terms of new use cases. The other thing kind of wanted to highlight is the shift that we're seeing as a move from just experimentation to actual execution. And I think, Wayne, you mentioned it's in the input really focusing on business value, right? So at this point in time, I think a lot of companies have dabbled in Gen AI, tried different models, different tool sets, maybe built a few prototypes. But now they're really looking to actually drive value at scale and operationalize Gen AI solutions. So that means more of a focus on use cases with clear ROI, building the right data foundation to actually support productionizing those use cases and actually like defining success metrics from day one. So I think while like the excitement and hype is very much there, I think there's been more of a focus recently on production rather than experimentation at this point. So a lot of exciting new trends and use cases there.
That's super interesting. Just to double click on that, it seems like you have to create these like awesome solutions for your customers and fairly quickly. Can you talk a little bit about what AWS services are allowing that you're using that allow you to innovate so quickly for your customers?
Yeah, absolutely. Obviously leading in pretty heavy on Amazon Bedrock, especially with a lot of the new features that have been released since reInvent last year. Bedrock agents, knowledge bases, multi-agent collaboration has been huge in some of these agentic architectures that we're building. Moj, maybe you want to share. I know you've been really excited about MCP servers lately and building a lot of interesting things. So maybe you can talk a little bit about that.
Yeah, absolutely. I'm excited to show like a demo of what we built for a global manufacturer. and they were struggling to surface and act on their critical documents like design specs, maintenance manuals, compliance reports, like buried across multiple silos. And to tackle this, we built a GenAI Power solution using AWS services. They started with powerful retrieval and has now evolved into agentic platform that can actually take action. And the key features of this system include like knowledge-based management, where user can spin up and manage multiple knowledge bases with like one click, like smart document processing that ingest and like parse, process many document formats, advanced search for fast and accurate retrievals, like internal and external tool and database integration to trigger real world actions, and you're adding more and more tools and integrating more databases. And we have advanced agent orchestrate multi-step workflows to chain various tasks like checking inventories, generating reports, sending emails, and all that cool stuff that can be done by a smart agent. And best of all, it's fully customizable and deployable in client's own environment, like tailored to the exact utilities clients need and the data sources they want to connect to. So yeah, with that foundation in place, let's jump into the demo video to show you some of the capabilities of the system we created.
Yeah, that's it. I'm super
Yeah.
excited. I love demos. That was super cool. Let's take a few minutes to talk about what we saw there. So, can you talk to us a little bit about what that demo did and what kind of solution and what it accomplished?
Yeah, actually, initially we started with solving some of the problems that our client had. So they wanted to create different knowledge base. They wanted to be able to create different knowledge bases, but they didn't want to go to like all that coding and stuff or go to AWS UI and do that. So we streamlined all that process using AWS Bedrock. And we use Bedrock data automation a lot for ingesting and processing data, and it helps us a lot with document ingestion because it supports many types of documents like PDF or text files, like even like code files, HTML, like many document types. So it streamlined the process the help of actually with the help of like different services they have, and even like for very complex figures that you have, like block diagram or like user manual, very complex like layouts that you have in your documents. It uses powerful LLMs to like transcribe them, so your knowledge base is not just like some text. It includes it, and it is enriched with information about like diagrams and like pictures and figures and all this stuff, and it helped us a lot. And then we switched to more agentic workflows, like connecting our, if you want to call it the chatbot, connecting the chatbot to different data sources or like client databases and data sources and tools that we have available. So we enabled that agent to act on our behalf to streamline process, to find availability stuff like different people and book a meeting, to like create a report about the inventory and like send like make it as a report and send it to the most relevant person and assign the task to a person who is like mostly available. And all of the stuff are streamlined using Bedrock agents that we are using in the back, and it helps us a lot, and it helps clients a lot with like automating stuff, doing the stuff faster, and get rid of what's boring for you to do, so it performs the job for you. Yeah.
Wow, super interesting. Very nice demonstration.
Yeah.
Super innovative.
Thank you.
So since yeah, I mean this is like an impressive thing that you've built, and I think a lot of our listeners are interested in understanding some of the lessons that you learned as you guys were building this, right? Because like what you have is really cool, but it's also true that like you had to figure some things out, or you had to you know you had to get it, you had to actually make it. So is there any practical advice that you can offer some of the folks that are listening, if they're trying to approach this subject themselves, like how they get started, other than obviously first like
Yeah.
calling you guys?
I can say that like technology moves very fast, and we have to keep up with technology so that we can take advantage of the most innovative stuff. So that like if I wanted to build this demo, like build this like solution last year, it would have taken me like much more time. But now with these new AWS services, they streamline the process, and we have to be aware of the available services and the offerings, the new offerings of AWS. And also we always have to be careful about like security is very important, because you have services that are connected to your like data sources, have to be very careful about security. And like I think the most important thing is that like building prototypes is very different than productionizing and scaling. There
Yeah.
are a lot of things that you have to consider to bring something from POC to production.
Yeah, something I'll add to that as well. I think even before the build stage, and we kind of talked about this a little bit at the beginning, right? It's about investing in the right use case, right? That will result in real business ROI. And I think we saw for the first like couple years, organizations been experimenting a lot, running prototypes, and now they're going back and saying, hey, which use cases should we really be investing in for the long run? And that's where I think Adastra can really help early on in that journey in use case prioritization. Like I'd say we see two kinds of customers. One, they've started prototyping, they know what use case will result in ROI. On the other hand, we have a lot of customers that are coming to Adastra asking us, where do we get started? What use cases actually make sense for our industry? And we actually run something called AI days with our customers that are really focused on like use case ideation and brainstorming. So these can be like 1 to 3 day workshops or sessions where we sit down with key stakeholders across business and IT, and help do a little bit of an art of the possible. If it's a manufacturing customer, we'll present and share demos and use cases on what we're seeing as effective GenAI use cases in the manufacturing space. And then just to get them to start kind of ideating and brainstorming ideas. And then the later parts of the workshop, we actually run these almost Shark Tank style sessions where we have the customer pitch their ideas to us, and we do some Q&A and start getting an understanding of what the kind of reach, impact, confidence, effort of these use cases are. Then we take all that information back and help them prioritize what the most impactful use cases will be. And for the top like 3 to 5, we'll build them a detailed roadmap, TCO, architecture, and what it'll take to actually bring that use case to production. So before even like talking about the technical aspects, we actually help customers understand which use cases make the most sense for them and their business. So they're not wasting a lot of efforts and getting stuck in kind of the POC stage.
Awesome. That's awesome how you're helping your customers innovate so quickly. I'm super impressed with the innovation you guys are doing, especially around the AWS tooling. Can you tell us where our listeners and followers can find out more information about your company and even how to contact you personally if you want to put your socials out there? How can we contact you?
Yeah, absolutely. Moshe, if you maybe want to share, I think we have a little splash page with a QR code, so you can use that to like book a 30-minute ideation session with us. I know we were talking about summits earlier. We'll also have a booth at the upcoming New York Summit, so if you want to find us there, we'll be more than happy to chat.
We're awesome. Well, thank you so much for being here. I love the innovation. Please keep up the great work because I'm super excited about the tooling you guys are building, and I'll hopefully get to play with some of it pretty soon.
So thank you so much for having us.
Absolutely. Thank you.
Awesome. Well, that is actually our first guest, but the show is not over. We actually have another guest, and we'll have them up in a few minutes. So stay tuned, and we'll be right back. Hello and welcome back to GenAI Live. My name is Brian Terry and I'm a Senior Partner Solution Architect here at AWS, specifically focusing on GenAI migrations to Bedrock. And I'm here with my co-host, Wayne. Wayne, how would you introduce yourself?
Hey Brian, thanks for kicking us off. Hi, my name is Wayne Sachs. I am a solutions architecture leader here at AWS. And it's always exciting to be here with you, Brian, and with our listeners from 8 to 9 a.m. Pacific every Wednesday, where we talk all things generative AI and AWS partners, really to just get a sense of all the things that our partners are doing in this space, the challenges that their customers are bringing to them, and ultimately the solutions that they're designing and delivering back to those customers, to help move the technology forward. And today we have, we had a great conversation with Adastra, and we've got another one with our next partner coming up. But yeah, this is exciting. Awesome.
Yeah. So just to expand, this is a live show, so we're actually here live. So yes, we are live. So if you have questions, please post them, and we'll try to get them in as much as we can, because I know there's a lot of questions about what the partner's doing and this innovative thing you may see, and we'll try to answer those if we can.
Yeah.
All right. So how about
So-
we bring in our next guest?
I think we should. I think we should.
Hello. Welcome to the show. How about you introduce yourself?
Hi, thanks for having me here, Brian and Wayne. Yeah, my name is Jiang. I'm coming from Zillis, Milvus. I'm leading the developer relations of open source micro database Milvus, and also the responsible for the solution architecture of the fully managed version of it called Zillis Cloud. Really happy to talk about generative AI and powered search and information retrieval in general.
Awesome. So thank you for being here. So let's talk. Tell us a little bit about your company.
Oh yeah. So yeah, we're a Zillis, and our main product is called Milvus. It's an open source vector database that we are maintaining and we created several years ago, a while in the back. And since it has been a journey, we kind of invented the term vector database before there was a term vector database. At the time, that was called the retrieval infrastructure for machine learning generated embeddings. It's a very geeky term that only a few people like in Google and Facebook, they know that. But over time, this embedding or machine learning model based retrieval has gone more and more popular, and this concept vector database has also gone viral. Probably along the same time that ChatGPT got being used by anyone, rather than just a niche community of researchers. So since then, yeah, there has been a lot of change in terms of the adoption, in terms of how people see information retrieval and the whole infrastructure that powers it. So I think we are from a traditional perspective, we are the pillar of information retrieval, like a database that you can stuff information into it. The information is represented as a bunch of numbers that people really cannot really comprehend, but machines, they are good at understanding it and using it to find semantically related stuff to you. That was kind of the traditional way of seeing this piece of the infrastructure in the tech stack. But over time, people got really excited about generative AI. So I guess the story around this has changed a little bit. So people say, this is a memory for agent. This is something that you just stuff in, and then you can find the information. And somehow a large language model can rephrase that in a human-friendly way. So suddenly we become the pillar of RAG, or retrieval augmented generation. Like if you are dealing with any chatbot, asking questions about softwares, or asking questions about the location policy in your company, there's probably a vector database behind that powering this kind of search and give you related information, so that large language model can use that and then just act as a human being, as if it was a human being, and then answer this question for you. And we are that vector database. But we are not any vector database. We are the scalable and cost-effective vector database that's built for production. There's a lot of vector databases if you are in this domain. Some are easy to use, easy to get started. Some are relatively complex. We are those. We are on the sophisticated side of the spectrum. Our architecture is fully distributed. It got a lot of components so that we can handle this trade-off between different components handling different types of workload or different parts of the workflow, so that it gives flexibility in terms of scaling up in the production. And we have worked with a lot of great users in the open source community, and also with the paid customers for the fully managed version. And we scale them. We scale their workloads, search workloads, from say 1 million vector to 10 billion vectors. So scalability and dealing with serious production and mission critical workloads, that's our strength, and that's what we are spending a lot of effort on.
It's impressive.
That's really cool stuff. Wow. Um, so with Gen AI models, right, are like just generating massive quantities of embeddings. And it doesn't seem to be slowing down. So how are you guys helping to sort of manage that onslaught?
That's a really big question. Well, usually I would like to look back to the history. So information, the blowing, the kind of explosion of information, that's not a new thing. It actually happened once in the past, like around like after dot-com boom, there was like a lot of information showing up in the on the internet, and then what came to solve that problem was Google. Right? So there was a search engine that helps you find information from find the useful information from an ocean of web pages and other types of content. So that thing has actually happened once, but this time it's getting even worse or better. In terms of a business, that's a better, but in terms of a technical problem, that's worse because large language model can just generate a lot of information in a very short period of time. There are so many people asking questions, and there are like a lot of models deployed, anywhere generating answers to that, and that becomes information as well. It probably materialized somewhere, say on the internet or in your in some particular applications, walled garden, right? So or there is, say, image generation models that can generate photos with a lot of creativity, which is faster than what you can do with an iPhone and clicking on the photo button. So yeah, there's a lot of information showing up after this generative AI wave, and our resolution to that is, of course, we build more powerful systems so that we can store that information. But also we were thinking from another perspective, which is how valuable those information are. So traditionally, we are mostly dealing with highly valuable information that if you want to do a search query, you want the search query to return within maybe 10 milliseconds, or worse, like for RAG, because you need to spend a few seconds on generation, probably 100 milliseconds, that's fine. But still, that's like on the millisecond level, right? You want the result now, immediately. There was a saying with Google, like if the search is slower by 10 milliseconds, then there's like $10 million being lost within an hour or something. That's not a joke, because I work for Google Search, so I know that's actually true. We do care. Back in that time, we do really care about the search latency. So that's or it's a recommender system. Say if you open some application on your phone and then you expect a news feed to show up immediately, right? You cannot really tolerate a running circle of something running for even 500 milliseconds. That's really hurting the user experience. So all of those are online use cases, and the vector database, especially Milvus, the one that we are reading, that was designed for this kind of workload, so that on a high level, it kind of stuff all of the information into very expensive RAM, so that it can be retrieved really fast. Say if you are using HNSW, indexing algorithm is pretty much sending all of the information into RAM, so that, say, if you have a billion vector, that's probably several terabytes of data, and you need several terabytes of RAM, and just to serve this information on online fashion. But a lot of times, for the information generated by a large language model, it's probably some kind of archive, right? I don't want to say garbage, but it's some kind of archive information a lot of times. You don't really need to find that information within 20 milliseconds. Probably within 5 seconds, that's fine if you want to explore with this information. A real-world example for that is actually large language model training. Because in training, you need trillions of tokens. That's a lot of information. And also you need to do some curation so that you can make the model perform as you wish by curating the data to teach it, right? It is pretty much it's kind of similar to your training data. in some sense. So to curate the data, you need to kind of find information that you want that's pretty much retrieval or search. So in that kind of workload, it's dealing with a whole lot of data, but that data doesn't need to be returned within 10 milliseconds because you are kind of doing this offline tidying up or offline processing of the information. Another example is in autonomous driving. So those electrical cars, they collect a lot of information from the road, and let's say those are kind of frames from the videos. Those images, there could be easily like 10 billion, 100 billion of such images. And to train a better autonomous driving algorithm, like, it's better that you refine the information, or sometimes you want to find some corner case, like this particular road, which looks really weird. And I want to find this photo of this road, of this crossroad, and maybe even in rainy weather, like in extreme weather condition. You want to find that information by specifying the semantic in your query, but you don't really expect this query to return immediately because you are not a consumer. You are probably a data scientist dealing with a lot of such queries. You're okay with 5 milliseconds or maybe 5 minutes of search latency, right? Because you are doing this in batch fashion. Or sometimes it's even a machine doing this. Right? So you probably want to process 1 million such queries within a day, but for each query, it doesn't really need to take a lot of time. So for those kind of offline workload, it actually deserves a different design of the system, not the same design that we built for the online query use case. Right? That's too expensive. That's too good for this use case. So that's another thing we're working on, which is called vector lake, which is kind of borrowing the idea of lake house. Like for data warehousing, those are not so valuable data that that deserves a relational DB like for online serving. That's too expensive. So that people invented this concept of warehouse or lake house. And that same idea really applies to vectors as well. For this kind of interactive search or offline search, really we can just stuff the information into, say, object storage and then build a query engine layer on top of that. So instead of fitting all of the stuff in memory ready to be served, they can be retrieved. They can be kind of brought up from the object storage to the query engine layer and then processed and then returned within, say, 5 seconds or 30 seconds. And that can save maybe 100 times of money in terms of the serving cost.
Yeah, so we actually had an interesting question come in. It says, how do you handle the possible state data with caching?
Stale data.
Stale data, sorry. Yeah, my
Caching.
glasses.
Yeah. So how do you manage caching stale data? It's like the question as old as time.
Yeah, that's really a good question that's coming from the operations in production. We also got a lot of questions like that. I think a few points, right? So depends on how stale the data is, basically. Right? Let's say if the data is still valuable enough that you want to serve to the users, whether it's 100 milliseconds, 500 milliseconds, but it's serving. It's not like I will get back to you tomorrow, right? As long as it's not that case, is we still see it as serving data, and the serving data you can store all of them in memory if you really want to say sub 10 millisecond latency. But if you can tolerate 100 millisecond or 200 millisecond latency, you can use disk. If you can tolerate a little bit more, we have this thing called tiered storage. It's available in both Mailbus and fully managed Zscaler Cloud. So this tiered storage is pretty much like multiple layer of cache, right? So the RAM, most expensive RAM is the top layer cache. It doesn't really, it cannot really fit all of the data. It can only fit a small portion of the data, but those frequently accessed things, you can store them in this. And then like below that, that's cheaper SSD, but still way more expensive than object storage, which is really code. So that we leverage these 3 different layers of storage to store the information. And there's a caching, there's eviction mechanism, right, to make sure that the frequently accessed information is in the top, like upper layer in this stack. A typical example of this application of this is consumer-facing products. Let's say for like smart note taking tools. Right? So for that tools, a lot of people, they store a lot of information in their notebooks, but they will never use it. They will never retrieve it. But there are some power users who has maybe not as much data, but they frequently use this product and they interact with their historical information, right? So you want to place those power users or frequently accessing users to the top layer of the cache, like RAM or SSD. And then there are like really cold storage, like object storage, that's really cheap. And AWS S3 offers a great product, S3, that can store a massive amount of information with really low cost. And those information, they can be stored in S3. And only when the user access this information will those data be retrieved will be kind of bumped up to the more expensive RAM or SSDs to be served. But usually those users, they don't really access this data more than once a year or something like that.
Awesome. That's super cool. So I think you have a demo for us. Is it possible we can take a look at that?
Yeah, why don't we get to that? I mean, talking is too abstractive. It's like when we, especially in the earlier days, when we kind of introduced the idea of information retrieval and vector database to the user, they were always like, what? A database can do search? That sounds unlikely, right? Or what is search? I was usually using some examples to illustrate the idea. So this is so far my favorite example, which is, let's say you have 100 million or 1 billion interesting images, like a massive amount. Maybe it's a Flickr or something, right? There's a lot of photos that you have to. And sometimes you want to find these photos by semantic. And traditionally, what we did was, you search by text, and then those information, all of the photos, they are labeled with text. So it's pretty much like keyword map. That's not interesting. So what vector search empowers is search by semantic. And the semantic, I guess the basic version of this is that semantic can be expressed by another image, which is, say, this red car, right? That's an image expressing our search intention. But what if I want to actually find something else? It's similar to this one, but actually slightly different. So I want to find something similar to this shape, like a sports car, maybe a convertible, I don't know, but in blue color, right? So there are awesome embedding models that can do this by taking both an image and a piece of text as input and kind of fuse the search intention behind those two pieces of information into one single vector, and then search among an ocean of other vectors, an ocean of other images represented by the vectors, generated from the same model. So this is what it unlocks, right? You can search with your intention and kind of adjust the intention expressed by this image by some text, right? I don't want the red color of the car. I want something similar with blue color, or this is not a fake. Let's try yellow, or just name any color that you want. So as long as this corpus has such information, it can actually retrieve. Right? You can see, all of those, they are sports car, they're with yellow color, but the lower ranked, the ninth best or 10th best, they are actually not technically yellow color anymore. I think this model doesn't always do the best, so that you can also re-rank by using large language model. But anything before this, that was done purely by the embedding model and vector database. So vector database is the facility that can store the vector information and then retrieve this within really strict latency expectation. And Milvus, I think so far, we have put a lot of engineering effort into this to make sure that I can reliably return the result within 10 milliseconds, right? If that's what you want. But let's say if you want 100 milliseconds or even more than that, and you don't want to pay as much, Milvus also provide the flexibility. Same applies to the fully matched version of it as well. The other example is I just want to quickly show another kind of interesting query. Say I want this in a construction machine, but I don't want the real construction machine. I want a toy of this. So by searching this, again, this thing together converted by embedding model into a vector, and then search a billion vectors in your corpus, and then return the top 100 or top 10 to you. Right? So as you can see, the top ranked results, they are actually toys. This one, I don't think technically this is toy. This is probably a real vehicle in the snowy weather. Right? So again, it doesn't always do the best. If you would like to pay way more cost, way more like latency and compute power, you can use a large language model, a vision language model, to kind of read each single image and then re-rank it. And then, in this case, it does give slightly better results. And also you can let, what if I just curious about snowy weather? So I want something like similar to this, but also in snowy weather. As you can see, this time this one got bumped to the first choice, and all the other choices, I think they're pretty decent in terms of matching the semantic intention of the query, of the search.
Yeah, no, that's really impressive. It looks like we might have lost Brian for a minute. That's okay. It's just you and me now. That's really cool. No, I love how this is really like, it's a powerful example of vector databases. I haven't seen it kind of so clearly and cleanly displayed. Nicely done. I like it.
Yeah, there's actually another quick example I can show, which is more, I would say, more popular among the developers, or you have probably seen this like so many times. Basically, it's an AI bot that can, you can ask questions about it. In this example, let's say, we recently released the latest version of Milvus 2.6. It got a lot of great features. This AI bot, it can read through those, it can actually search through those software documentation, which introduces about features and use like all the usage instructions, and then return the result, a really grounded result backed up by the real content in this corpus, rather than just making up things by the large language model. For example, this case, Mills 2.6, it released a few great features. For each of the feature it mentioned, it actually will give you a reference, which is the software document from the search result, right? So those things, I think it has been used really frequently by a lot of developers. In this case, we actually have so many developers enjoying this chat AI bot, so that they don't need to use Google to search the software documentation of Milvus. And also they usually get the result they want.
Nice. And we only have a few minutes left. So one of the things I did want to make sure that we had a chance to talk about, not thinking about like comparing yourself to other vector databases. Like, you guys stand on your own, you are your own thing. But there are options. There's plenty of choices. There's a lot, as you mentioned, there's other vector databases around. Why is a customer, like, when a customer runs into X problem, you're the obvious solution? Like, what are those types of problems that really lean into your strengths?
That's a really good question. I would say from our operations, what we see is that when a customer enter production and then they are serious about this workload, it's no longer a demonstration of what vector database can do or search can do for you in the generative AI space. When they have, not 1 million vectors, they have 100 million or even more than that. When they have not like 2 queries a day, they have 100 queries per second. When they have that kind of serious production workload, that's when they really like us. I mean, they probably have liked us before that. I'm kind of cocky sometimes, but that's when they really, start to become friends with us, because they know, there are not so many options on the market that can actually do this. There's probably 100 options that you can use to build a Twitter demo. That's true, right? So no argument on that. But I would say production, scalability, And sometimes also about cost, right? So if you are dealing with a billion vectors, you need terabytes of RAM, which is probably I don't know, like $1 million, $5 million a year of cloud bill, right? If you're dealing with that, you do care about the cost effectiveness, right? Can I save the cost by 3 times? Sorry, AWS. I don't want to, do bad to your revenue. Sometimes the customers they do care about their money spent on the infrastructures. That's also what when we do good. For example, we have this Rabbit Cube, this really like crazily good battery quantization algorithm that can save 70%, 50% of the RAM cost, and still offer the same kind of search quality to you. Right? So we put effort on those kind of research. We work with the academic researchers and we productionize that into Milbus and Zscloud. I would say those kind of things that someone operating a production level database or search engine, what they worry about, that's where we do good, and also that's the reason why users really like
No,
us.
no, I love it. Like to me, it's the practicalities of production scale, like full stop, and that's really cool. Because like you said, there's lots of options, and lots of people are doing really interesting work in this space. But if you're dealing with 100 million queries and massive scale, you have to be very thoughtful because it can get out of control quickly, operationally, expense, whatever, right?
Yeah. And here at AWS, we love to see customers' bills go down. So like it's not a thing. We don't want to go up. We
No,
want to
this
stay
is
down.
better. This is better. Yeah.
Thank you.
Yeah,
for
no,
helping.
we want our customers to get the absolute most out of every penny they spent. We really do. All right, we got a minute left. 2 minutes. How can our listeners get to you? How can we find you when inevitably we have a massive problem and you're the ones to solve?
Yeah. So the most, like, if you can bring up the screen, the easiest way is go to milvus.io. This is the website for our open source project. And also this.com if you want a fully managed service, but you can also just click on this and and if you want to, we are human beings. We're a real person behind this. We're not robots. So if you want to talk to us, you can actually sign up for the office hour or just join our community. So on the top there's community, more channels. We are on GitHub if you want to report issues. Discord if you want to chat and ask questions. And also ambassador program if you want to join the community and help grow the Milvus community by yourself or in your local region. And lastly, if you have a question, or if you want to talk about your use case, you want to get some advice on how to productionize your vector search, you can book a Milvus office hour. We have quite a few sessions every week. So those are ways to get in touch with us.
Thank you. That is awesome. Thank you. Thank you for joining us, listeners, viewers. Thank you for viewing us. Brian, thank you for co-hosting.
Thank you.
Thank you both for having me here. I'm really excited about the questions being asked by the audience, and also you guys. Really happy to share more about Milvus, and connect to me. And my name is Jiang Chen. I'm pretty active on LinkedIn as well. Just search for Jiang Chen, Zealous, or Milvus, and let's get connected.
That's
great. Thank you. Well, to our listeners, to our audience, thanks for joining us today, Wednesday, from 8 to 9 on GenAI Live. We've had a great show. We hope to see you next week.